In this video, I'm going to do a identity and a reductions question. And so let's dive straight in. When I see a trig identity or something that I need to reduce and simplify, the first thing that I do is I highlight any 90s or 270s because they're going to jump out for me and remind me that I need to co-ratio. The rest I'm going to just be looking in my quadrants to see if they're positive or negative. I'm also looking for any big angles bigger than 360 that I need to minus. So if there was a 500 here, I would minus 360 to start, or like this one, if there are any negative angles, I'm going to add 360 because that will then simplify to just being 180 plus this x. And that helps me to see a lot quicker which quadrant I'm in. And so what we've got for question 5.1 is this will co-ratio, so sine changes into cos. 180 plus is in the third quadrant, and that's where cos is, negative. Then there's a plus. Then keeping things in brackets, I'm going to not waste time and steps in my exam. Tan is just sine over cos. So straight away, I'm just going to expand that identity to sine over cos. Cos x is feeling a bit left out, so I'm going to put it over 1. And this we said was 180 plus, and so that's in the third quadrant where sine is negative. And again, it also feels a bit left out, so I'm putting it over 1. All these subtle things of keeping brackets, doing each reduction at a time, changing tan to sine over cos. When something becomes a fraction, letting the other things become fraction, just make it that much easier in the middle of my exam to see what can cancel. Careful, this isn't sine minus sine is nothing or 1. It's cos times a negative cos is just negative cos squared. And a sine times a negative sine is negative sine squared. And so that is perfect because I can take out a negative 1 in a sense. And I'm left with cos squared plus sine squared. And I know that that's an identity in and of itself. That's just 1. So minus 1 times 1 is minus 1. Question 5.2. I'm going to reduce each of these in the same way, just looking which quadrant. And in the back of my mind, I've got two things going on. So I say if you look in your pair of shorts and you're seeing flip, I don't know what to do, I'm in the middle of exam. In the one pocket, you've always got co-ratios waiting for you there, back a buddy. And in your other pocket, you've got special triangles. And so you can always keep coming back to those. If you're ever feeling completely stuffed in a trig exam, look in your pockets. So sine 315, so that's about here. That's in the fourth quadrant where sine is negative because it doesn't belong to him. And you're saying how far is 315 back to the nearest x-axis to 360? It's 45 away. Tan 210, that's about here somewhere. What is tan in the tan quadrant? It's positive. And how far is 210 back to the nearest x-axis? Back to 180, it's 30. Sine 190 has just crept into this quadrant as well, where sine is negative. And how far is 190 from 180? It's just 10 away. Cos 100, that's about here. What's cos in this quadrant? It's negative. And 100, I don't go to 90, I always go to the nearest x. So that's 180. So how far is 100 from 180? It's just 80. So it's negative cos 80. Last one, sine 120. That's also about here. Sine in the sine quadrant is positive. And how far is 120 back to the nearest x? It's 60 away. So you want to show your teacher in the first step that you've reduced everything and that you know whether they're plus or minus. Then the next thing that you can do is you can just notice there's a weird angle. These are all special angles, but these two are weird. And so if an angle is just out of place, you can always think co-ratio. And that's where sine, so if it's negative, it will stay negative. It will change to cos of whatever angle is needed to get this to 90, so 80. So I've got a negative cos 80 and a negative cos 80 in a sense. and so they're going to cancel. I'd obviously in my exam show that I've done the co-ratio. And then these are all special angles, and so I'm going to just draw them for you really quickly. And it is helpful, as quick as you see me drawing now, to push yourself to see if you can draw the special triangles. I would do it at the start of any exam that I wrote, just so that I have it there waiting. I know your calculators can do it as well, but it's just good to have. So minus sine 45 would just be minus sine from 45 would be 1 opposite over root 2. Tan 30, I'm going to look up here from 30, and tan is opposite over adjacent. So it's 1 over root 3. And then on the bottom, I've got sine 60. So looking from 60, sine is opposite, root 3 over hypotenuse. That, for me at this stage, isn't that helpful. And so I'm just going to take one extra step where I bring the bottom fraction to the top. It might be easy on my eye to see what can cancel. And so if I bring a fraction to the top, I tip and times. So the 2 would come to the top, and the root 3 would go to the bottom. And what that will do is it will give me, if I times all my top numerators together, I get minus 2. And if I times the bottom, root 3 and root 3 is just 3. And there's a root 2. So that is your answer. Then this one I'm going to show you now is just bonus for being fancy. If you wanted to get a little bit further, a little bit simpler, then the number 2, or any number for that matter, can always be split up as a root times a root of that number. So I could split up 2 as, so there's my 2, it's just become root 2 times root 2, because that is 2. And that's over what I have here in the denominator. Why would I do that? A, just to be fancy and show you a cool trick, and B, to show you that you could cancel further if you were forced to. In this question, are we forced to? Yes, because we're trying to get to that specific answer. And so it was immeasurably helpful to know this trick of splitting up to one other one. If I had 5, that would just be root 5 times root 5, and you can do it for any number. And so I hope that you found that reduction of numbers as well as terms with x's helpful. If you did, please like this video, subscribe to our channel, and share it with your friends. Thanks.